Okay, continuing on here, lesson 26, one-sided Chebyshev inequality connecting Markov and Chebyshev. So recall Markov inequality, the probability that x is greater than or equal to a is less than or equal to the expected value of x over a. Just make a note here that x is non-negative. And Chebyshev is that the probability that absolute x minus mu greater than or equal to k times sigma is less than or equal to 1 over k squared. So one-sided Chebyshev here, assuming the mean is 0 and the variance sigma squared is finite, the probability that x is greater than or equal to a is less than or equal to sigma squared over a squared plus sigma squared for a greater than 0. So I should make a note there and mark off here. X is non-negative. We also have a greater than 0. Okay, so suppose that x is greater than or equal to a, and then we're going to add a positive number b to both sides. So inequality holds, x plus b is greater than or equal to a plus b. The probability of x being greater than or equal to a is equivalent to the probability that x plus b is greater than or equal to a plus b, which is less than or equal to the probability that x plus b squared is greater than or equal to a plus b squared. So in general, that's an inequality there because of the negative case where it's possible that when squaring both sides, you might get additional solutions here. Although x plus b is not going to be negative in this context here, but in general, that inequality holds that if we have x plus b is more than a plus b um, squared, if you square both sides, that will certainly still be true, and could also be true for additional values if you did have negative numbers. Now we're going to apply Markov to this expression here. So we get that the probability that x is greater than or equal to a is less than or equal to the expected value of x plus b squared over a plus b squared. So squaring out x plus b, we get x squared plus 2bx plus b squared. Denominator is a plus b squared. Apply the expected value to each piece in the numerator. Now, we know that the mean was 0, so the expected value of x is 0. So the middle term is 0 there. The expected value of b squared of a constant is just itself b squared. So we're left with the expected value of x squared minus b squared over a plus b squared. Sigma squared is the expected value of x squared minus the mean squared. Now, we know the mean was 0, so we're getting that, in this case here, the expected value of x squared is sigma squared. And so we can replace that with sigma squared. And now it's just basically algebra to complete this proof. We have a sigma squared plus b squared over a plus b quantity squared. We're going to express b as sigma squared over a, which is definitely positive. I suppose it could be 0 if sigma is 0, but if sigma is 0, then all the values would be the same. So we replace the b with sigma squared over a. Square that out, we get sigma to the fourth over a squared. Factor out a sigma squared in the numerator. Factor out, it's a little trickier now. We're going to factor out 1 over a, so you have to make the 1. This 1 here is going to have to become a over a, and then we can factor out a 1 over a in the numerator. And then we can get a cancellation here. So we get a cancellation that a plus sigma squared over a cancels out with the quantity squared. So one of those cancels out. It goes down to power 1 there. Yeah, we don't need this step. Canceled it out. We're left with sigma squared over a plus sigma squared over a. Common denominator of a, it's a squared over a plus sigma squared over a. Multiply through by a. The a's can be canceled out. We're left with sigma squared over a squared plus sigma squared. All right, so that completes the one-sided Chebyshev. We'll do an example in the next video. As always, if you have any questions, please feel free to contact me.